Okay, welcome back. This is the fourth module for the third week. So we will start where we left in the previous module. I was giving you some examples of how, like basics of how the life cycle is done. If you remember, we looked at this slide, like the last, just the couple of last two slides I have reproduced here just to kind of recap of what we have done in the previous video, the last module. So again, just a quick recap. You start from the raw material acquisition, you go to the material processing, then manufacturing and assembly, use and service, retirement and recovery, and treatment and disposal. So you are looking at from cradle to grave. So that's we talked about that earlier as well. And then in between you may have some reuse, remanufacture, closed loop recycle, open loop recycle. And for each of these units, we have material and energy input into the process, and we have waste being produced. And this waste doesn't have to be a solid waste, could be a liquid waste, could be a gaseous waste. So this is what a product life cycle is, from cradle to grave. Again, I mentioned several times in the last video that you need to really understand this. So just I wanted to recap before we make further progress into this particular module. So we also looked at this slide. This was the last slide we looked in the previous segment, where I said that based on the ISO definition, we need to have a goal and a scope definition, inventory analysis, which is the biggest part of doing an LCA exercise. Then you need to have impact assessment and interpretation. So in this module and the module after this, we will be going into each of these in great details and with several examples. I will give you some small examples, then we will cover a big example where we'll go step by step of all these aspects, which will make you clearer in terms of in terms of the methodology of how to conduct an LCA. And towards the end of the course, if you look at the syllabus, we do have several case studies. So again, we'll go back. Here I'm using these examples to explain you the concepts, and then we will apply these concepts again in several of the case studies, which are many of those case studies are essentially the case studies which came out of my research projects over the last few years. So we will talk about several, and some of those research projects already have been converted into like technical reports or publications, and I'll give you a link of that if you want to read further. That will be towards the end of the course. I would probably maybe the last week will do that. But so in terms of LCA, so let's look at one very simple example. So this is a say we write. We all are learners, whether as a student or a professor or an instructor or a teacher. We have to write things, make notes. So there are different ways you can write it. So here there are, say if you take a two example of an wooden pencil versus mechanical pencil. So these are the two examples we are looking at. So wooden pencil, very common, you go and buy. Nataraj used to be very common in India. Now also there are other wooden pencils out there. So wooden pencils and versus the mechanical pencil we'll look at. So the first step, if you remember from the previous slide, goal and scope. So what is the goal of these two two different products? Goal is to write, isn't it? The goal is to write. And for here we are trying to, the goal for this LCA exercise could be compare two writing utensils for classroom reuse. So we are trying to compare this writing utensils for the classroom. Say if you, we can take a classroom environment where some people are writing with wooden pencil, some people are writing with mechanical pencil, and then we have to compare in terms of their environmental footprint, which one is better. Now if you look at the wooden pencil, the scope in terms of the wooden pencil, we have to have a process flow diagram, how these wooden pencils are made and its uses. So since it's wood, it has to come from lumber, the wood, that is the lumber forest. So we need to have cut the trees to get the lumber from the forest, then it will come to the lumber mill. The T in between is the transportation. You see several T's in this process flow diagram, and all the T's representing the transportation from one place to another place. So lumber forest transported to this lumber mill. At lumber mill, you have you got like a stuff ready to make the pencil. Then from there you added, you need rubber. Rubber is that eraser which goes at the end of the pencil. If you remember, most of these pencils, wooden pencils also comes with an eraser at the end. So that's what we have, the rubber. Then we have graphite. which is the pencil, the things that we write. That's the middle part of any wooden pencil, or is the graphite lead in the mechanical pencil. Then it has to be packaged, and then there is also a brass. Brass, if you look at a pencil, wooden pencil very carefully, towards the end of the pencil, when there is an eraser out there, the eraser and the wooden part of the pencil is connected with a brass ring. So that's what we are talking about here. So if you look at this particular picture very carefully over here, you can see the brass ring as well. So that's all these stuff that you will use to manufacture. And once the manufacturing has been done, then it has to go to a retailer. For again, if you look at each one of these, rubber, graphite, packaging, and brass, each one of them has to be transported. So you see this transport T. So this is the transportation of rubber to the manufacturing plant, graphite, packaging. For the packaging, you need the cardboard, you need some like a sellotape or the duct tape. So those and then brass needs to be prepared and send it to the manufacturing plant as well. So that's where this manufacturing plant, where this pencil will be made. It will get sent to a retailer, to any shop, and then from the shop we will buy it, and when we buy it, we will use it. In between, when you are using it, we may have to use sharpener. Most very common sharpener is the mechanical sharpener, but in some schools now, and at some places, this electrical sharpener is also being used. This electrical sharpener that you see over here, although the video is a bit wrong, the pencil doesn't go inside, pencil actually comes out. So you put it in, it gets sharpened, and you get the pencil coming out. It doesn't just go and get disappeared. So but this is a example of electrical sharpener. But even if you use a mechanical sharpener, think about a mechanical sharpener, what it has. Most of the mechanical sharpener these days are made of plastic, which have a like you will have a blade in the middle, and then you also have a screw, like a very tiny screw, which keeps the blade on the plastic. So that's your like a sharpener, and either you use mechanical sharpener or you use this electrical sharpener, but it needs sharpening needs to happen from time to time. And then at the end, whatever is the here, most of the time when you are sharpening it, the wooden pieces are coming off, the wooden savings are coming off, and we are assuming that that is going to the landfill. We can also have a scenario where that goes to a compost plant. So this whole process from the lumber forest all the way to the end of life is the cradle to grave for these wooden pencil. So think about that. For as simple product as wooden pencil, you need to go through all these processes. So that's to take care of all the processes, and think about all the transportation. Like just for this small product, we had T's 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So we have to take this transportation data, and those transportation data mostly you have to find out whether it's a transport by sea, it's whether it's a river based transport, water based transport, or whether it is a you have like transportation by trucks, transportation by rail. So all those things, information has to be collected as well. So this all the data collection that goes with that, that was what the LCI is, that a life cycle inventory data, and that's very critical. So let's this was for the wooden pencil. Now next, if you have the mechanical pencil, so same thing, the goal is to write, but you, rather than having wooden pencil, we have this set of mechanical pencil, and we'll take one of these mechanical pencil. Now mechanical pencil, mostly they are made of these days, if you look at the mechanical pencil, they're mostly made of plastics. So plastics, either polyethylene or polypropylene. So that's what you have. Both materials are plastic polymers, basically large molecules used to make many products. So they are made of plastics. Where we get the plastic from? Plastic comes from oil. So you have the petroleum base, so it's oil. So you will have oil from the oil, polyethylene and polypropylene will be made. Again, the transportation involved here. Then you take it to the manufacturing plant where this mechanical pencils will be made, and then in the mechanical pencil you need again eraser. Eraser is there, graphite. Those graphite needles, like we call it lead, graphite lead. You can buy it in a separate like container, a small container, so you can for the refilling of them. Then packaging as usual for any product. And if you remember, if you have looked at any mechanical pencil, these mechanical pencils also come with a spring. You need a spring to put into the mechanical pencil. So all these things, stuff will go into the manufacture. then again it will go to retailer, it will be used, and at the end of the day, most of the lead will be used up, but you will have this mechanical, if the things gets broken down, you have this plastics going to the landfill. We have assumed a scenario of going to the landfill. So now if we have to compare, these were the two scope from cradle to grave. For both of the scenario, we have a cradle to grave scenario. That's the complete life cycle. These days we also talk about cradle to cradle. Many times I joke that although this cradle to cradle concept has come from the Western world, but like if you think about in India, many of us who believe in Hinduism, we think about punarjanam, like when you're rebirth. So cradle to cradle is very much a concept like rebirth. So we are talking about rebirth of the materials. So the materials which have been used at the end of its use, rather than going into the end of life, we are recycling it and we are bringing it back into the economy. So that's the concept of circular economy, the cradle to cradle concept, which is very popular these days. If you look at any environmental magazines or if you follow environmental news, you see this people talking about circular economy a lot. So coming to now, we have figured out the goal. The goal is to compare the mechanical pencil versus the wooden pencil for its writing. Of course, that's what the pencil is used for. Now, how we will compare? Is it fair to compare one wooden pencil versus one mechanical pencil? Because one wooden pencil will last if you are writing every day, day in and day out in your classroom, from a regular class hours, from say morning 8 o'clock until 2 p.m. you are using a mechanical pencil, so using a wooden pencil every day, it may last for a month depending on how much you write, how much notes you make, or maybe 2 months, and as opposed to if you look at a mechanical pencil, they may last for a year, or if you don't break things too often. So it will last for a much longer period than a wooden pencil. So will it be a fair comparison between a wooden pencil versus a mechanical pencil? The answer is no, because wooden pencil will get used up quickly. Wooden pencil requires much less energy to make and everything as opposed to mechanical pencil. So it's not a fair comparison. But if you think about in terms of their writing, wooden pencils versus mechanical pencil, what is the function? Function is to write. So when the function is to write, we have to look at what is their functional. We remember I talked to you earlier that this function and the functional unit, this concept again, try to understand that. So function for both of these is to write. So what we can take is, we can take a functional unit. We can take a functional unit of say 1 meter of writing. So if you have to do 1 meter of writing, which one is better? Whether we should go for a mechanical pencil or a wooden pencil, which one comes out to be better for 1 meter of writing? This 1 meter of writing is not like a hard and fast rule. You can take 1 page of writing, you can say 1 A4 page of writing with a standard like a spacing and this many number of lines, or 10 lines, or you can even say 10 A4 pages, 20 A4 pages, whatever. You can come up with a functional unit where the function is to write. So in this case, it's much simpler. Like where you are wooden pencil versus mechanical pencil, the function is to write. But sometimes when it's things may not be that easy, and I'll talk to you in a minute about that. So the function here is the writing. We can take the functional unit as 1 meter of writing. So for what is the function? Function is the service provided by the system. So what it does. So that is the function. So for this mechanical pencil versus wooden pencil, their function is to help us write. So that's why we said writing. Functional unit is we give the function a number value. The reason for that is we have to give a number value so that we can allow comparison between the products. So that becomes a reference point. So all these LCI data, that life cycle inventory data that you will collect, that has to be collected based on a certain like a basis. So here we can say 1 meter of writing using either mechanical pencil versus wooden pencil. So for for example, wooden pencil, they last for say 10,000 meters of writing. So whatever is the environmental impact for 10,000 meters of writing for that one particular wooden pencil, we can scale it down to 1 meter of writing. And similarly, we can say for the mechanical pencil, say one mechanical pencil may go for 10,000 or 20,000, 50,000 meters of writing, and then we can bring it down to what it would be for 1 meter, and then we can compare. So that's like a comparing what we call apple to apple. Both of them are giving us a function of 1 meter of writing. So in this case, things are much easier to do those kind of stuff. In some other cases, things may not be that easy. We'll talk about that in a minute. So in terms of the data for say for 1 meter of one meter of writing that we talked about, in terms of data, what kind of data we need? We need that what is the input going into the system, how much energy is being supplied, how much material going in. We also look at the labor and energy, material does include water as well. So we have energy, materials, which includes water, labor that goes into the system to make it. And what is the output? Output is our product, which is and could be output is what comes out of the system. It could also be like if you're producing electricity, it could be electricity, it could be materials, it could be goods, it could be services. And then we have certain byproducts or co-products. Byproducts that could be, some of these are waste. It could be liquid, solid, gaseous waste. Gaseous waste we also call emissions, and we can have some co-products coming out of that too. So we have to do kind of an inventory between those two. So we do have an inventory which is called a life cycle inventory analysis. So we have to collect data. So that's very, very important. We have to collect the data coming out from this to compare. So that's why, if you remember the previous, we had looked at some of the previous module. I was emphasizing you a lot on the data quality, how the environmental data is collected, just because of this particular reason, because we have to collect a lot of data. And if your data is bad, say if you have a, what is the life cycle analysis, these days the softwares are out there, and I will introduce you to some of the softwares as well. So say you have a software package, and that package you are entering and you are inputting a certain data, but if the data quality is bad, the software cannot do any magic to it. Whatever is the output that will come out will be bad anyway. So having the good quality realistic data for doing good life cycle analysis is very, very important. That's the reason we looked at some of those videos last week and early this week, that in terms of the data quality, why, in terms of how the data is collected and all that. So again, kind of emphasizing on this particular slide, for the life cycle inventory analysis, the inventory analysis is essentially the data collection part. So what are the things we look for here? We want the time sensitive. So past 5 years. Now why we want this time sensitive? Again, you should ask this why question. For everything, you should try to ask this why question to get yourself comfortable with what you are getting the information. So why time sensitive past 5 years? Because the technology keeps on changing. So if you, the first point that we have listed here is time sensitive past 5 years, because the technology keeps on improving. Just look at the electronics technology. I give examples of electronics from time and time because we all relate to it much quicker. We all have some electronic products with us, so we can think about that in a better way. So like 5 years ago, whatever the laptop used to be, today laptop is much different. Even the cell phone 5 years ago, the way the cell phone used to be, today the cell phone is again much different, more powerful and much lighter. And so that's why the technology keeps on improving. Technology keeps on improving, and so that's why we are looking at the time sensitive of past 5 years data. Because if you have older data, that doesn't really give you the correct picture. So you are doing a LCA exercise, but you are actually you are being biased towards the old data. That may not be the realistic or what is happening today. Second point is the geographical. Does it match the location from the goal? So now, if your goal is to compare certain things in an Indian context, and the data that you generate, the data that you collect is all Western European countries or American countries or Canadian or American countries, including US, Canada and other places. So that's not fair, because the data has to be as close to the place where you are trying to get the study done, where you are trying to look at the impact. Although LCA exercise is a global exercise, it gives you impact on a global scale, but then the local data, the local information needs to be fed in, because we are trying to get the impact from the processes that is being used in that geographical region. So for that, you need to kind of rely, as I said earlier, most of the data that we have today in those databases and you will see those databases examples. So the most of the data that is there in the database coming from the Western European countries, some from US. We have some Indian data being generated right now as well. I think I mentioned to you earlier that EcoInvent, the company which looks at the data collection, which is trying to collect the data for all the standard unit processes for different things happening in industry, and so they are trying to collect the data and from throughout the world. Right now we are working with EcoInvent on a project where we are trying to collect data for the textile industry in India. That project also has FICCI, Federation of Indian Chamber of Commerce, as one of the partner too. So you have to have the data has to be geographical. One of the most important part becomes is your energy mix. So if you are using the energy data, say for example in Indian context, we use still our coal based thermal power plant is one of the major source of energy, but that's not the case in many other countries. If you go to the Western European countries, we have more nuclear, some places we have more hydro. So now if we take that energy data and try to use it in an Indian context, of course our results will not be correct, isn't it? Because they have different environmental footprint. At the very beginning of the class, I showed you that how the energy, like even just if you just think about from the water demand, water demand was so much different for different types of energy sources. So that's why your impact will be different. So this geographical region is important. Does it match with the location from the goal? Then you try to find out the technology, the best available technology for process. So what does that mean? For say if there is you are trying to compare two different products, and for that particular product try to use the best available technology in the market, so that you are not being unbiased. Usually older technology will be less environmental friendly, may not be true in all the cases, but these days as we are trying to go for more pollution prevention, green engineering, most of the companies are trying to have better technologies out there. So in terms of better technology from the environmental perspective, so in terms of the technology, try to look at the best available. Then it should be representative. We should not try to pick a technology which is just being used for say 5% of the product, rather than 95% of the product is not made using that technology, although the technology may be very green, but that doesn't, it's not going to give us a true picture. So we should get the technology which is representative. That means majority of the product made is made by using that particular technology. Then the data should be consistent, and this like as part of this data quality data, if you remember we talked about the QA/QC. So the fifth and sixth bullet kind of re-emphasizes the QA/QC over here. Data should be consistent, so it should match with the procedure, and should if you try to collect the data and again you should get similar values, and then it should be reproducible, like another person could also find it. So that's what the reproducibility means, that it's not that you found the data but others cannot find similar data. And again, part of that QA/QC procedure, you make sure the data is precise. So that's what it is talking about, the consistent reproducibility of a measurement. So it's not, that's why we talk about doing the replicates and all that. And then data should be complete, covers all the areas outlined in the scope. So again, this data collection part of this LCA inventory, life cycle inventory analysis, is the biggest task in terms of life cycle analysis that we do. So that's very, very important. Now another example, let's look at LCA in action. Let's think about this paper plate versus China plate. China plate is a plate you wash and reuse. That's the plate that we use, like similar to your La Opala set or the other set that you buy from Big Bazaar or other places. It's called China plate because I think the reason behind it is initially it was used in China and it kind of came from there. So if you have to compare paper plate versus China plate, now how will you go about that? So in terms of comparing it, again, if you remember, what is the function? There are several in this particular slide. As you can see, we have listed several questions, and I will try to go and answer each and one of them. And I would encourage you to think about the answers to these questions as well. So what is the function of these two plates, whether we go for paper plate versus China plate? The function is to serve the meal. It is the meal, like either you can serving the breakfast or the lunch or the dinner. So it's the serving of the meal is what is the function of this. Now in terms of the functional unit, can we compare one paper plate versus one China plate? Will it be a fair comparison? One paper plate in an ideal scenario should be used only once. Sometimes in like a university hostels, you may end up using it more than once, but usually it should be used only once. So so we will assume that normal scenario where you are using it only once. So you're using it once and then it gets thrown away. So paper plate is used only once. China plate can be used multiple times until you break it. So but when you are using multiple times, again, I'm not talking about the scenario in a hostel where you may be using the China plate without washing it from breakfast to dinner, but that's usually not the case. So we'll assume that after every usage you are washing it. So that's your plate you wash and then you reuse it. So the function is to serve the meal. Now in terms of the functional unit, we can take we have to pick a functional unit. Why we need to pick a functional unit? Again, the why question. Why we need to pick up a functional unit? Because we want to make sure that all the data that we collect, that LCI inventory that we collect, is based on the functional unit that we choose. So here, what will be an ideal functional unit? One paper plate versus one China plate is not a good one, because paper plate can be used only once, China plate can be used multiple of times. So it's not a fair comparison. So in that case, what an ideal functional unit, if you think about that, what is the function? Function is to serve the meal. So we can pick a functional unit which is related to the serving of the meal. So in that case, let's think that, okay, let's take a scenario where we serve 100 meals or 30 meals or 50 meals, something like that. So that could be the scenario where we can pick it up, where in terms of this much meals will be served. So say we take 30 meals, 30 meals for paper serving of 30 meals. So for that we need 30 paper plates. In an ideal scenario, normal scenario, we can use one China plate and we will use it. So it has to be washed 29 times to use for 30 times, assuming that first time it is already washed. So the functional unit is, say, 30 serving of meal. Now what materials and resources are used for it? The materials for the paper plate, of course the paper is there, and there will be some like it needs to be processed. There might be some glue because there is a different layers of paper glued together, so there will be a process associated with that. For the China plate, all the ingredients that go there, that needs to be made and all that. So what does it take to produce both? We have to make the list of all the materials. So that's what kind of your LCI inventory. Now we have to, in terms of all the materials that goes into there, what is their impact to the environment? So what are the impacts to the environment that we need to list? Is there any waste? Does washing of China plate produces waste? So when you are washing the China plate, you need detergent. The detergent is also coming from somewhere. The dishwasher, if you're using a dishwasher, you are using energy. You might be using hot water, so it's again you are using energy. So all these things has to be there. So all the what types of data you need, all sorts of data that you can think about in terms of the life cycle of these two products. You need to list them out, and then you do a LCA exercise to know which one is better. And once you have the data, once you have collected all this data in terms of different emissions coming out of this, different materials being used, we can find out in terms of what is the global warming potential. So that's the impact categories. We looked at the environmental impact categories. What is the global warming potential? So gases in the atmosphere, global warming is gases in the atmosphere that absorb and emit radiation. So what it does, it traps the heat from the sun, it doesn't let the heat go away, and then some of the global warming gases includes water vapor, CO2, methane, ozone, NO2. So that's one in terms of the impact category. These are some of the impact categories we looked at. Abiotic depletion, which is the consumption of non-living resources which you are getting consumed. Then human toxicity potential, whether it will have harm to the humans from chemicals in the land use, how much land is needed. So those are the impact we look at. Eutrophication, some of you who have taken a course on water quality or even in wastewater, you may be familiar with using the nutrients. Increase in chemical nutrients containing nitrate and phosphate, and that leads to eutrophication problem. Impact on land and water, overgrowth of plants, killing of organism at the bottom of the water, because the top level you have so much of an algae that and the lower level the oxygen supply gets cut off, and then then you have the water usage problem, mercury problem, acidification caused by acid rain, fuels, low pH. We have the smog issues. We are in the winter month right now, So we will have this the smoke in Delhi, which will come. We hear about that all the time. Winter or summer, we have then energy usage, solid waste produced, oil, and many more. So all these environmental impact categories based on all the emissions that is coming out based on due to the all activities associated with production of these material, we need to like find out the different impact categories. So where do we go from here? And so what is the purpose of all this data? We collect all this data and we look at their environmental impact categories so that as a scientist we can make recommendation to of the choices that are less impactful, which has the less impact. And then we can analyze a particular impact and focus on a solution. If we analyze a particular impact and that particular impact has too much like we see that this is a very high environmental footprint, we can as a designer, as an environmental scientist working with the designers, with the engineers, like a traditional engineers, we can come up with, okay, how to really what we can do, and as an industry and individual we can take a closer look at how the difference can be made. So this was kind of just to get you started in terms of like how this LCA is done. And we have given, like I have given you two very quick examples, one of the mechanical pencil and the traditional pencil versus the other one was on China plate versus paper plate, just to get you thinking of what are the thing goes in terms of developing this LCA inventory and all that. So next, like we will end this module now, and then in the next module I will look at a detailed example, and that example will it's a long example which you will see, and in that example we'll go into this more detail, like we'll go into very like small steps that we do, and so pay really good attention. Of course you need to look at this video, and after you understand things over here, the next video will be much easier. So if you need to like rerun this video and listen it again and again, go ahead and do that, and again I will see you in the next video. Thank you.